Hello, my darlings. We are beginning Unit 3, which is exponential and logarithmic functions. So this is page 1 of Notes 3.1, exponential functions. You saw a slight beginning to this back in the integrated maths, and now we're going to expand on it and do more reflecting and shifting than we did back then. So first thing to remember is if we have this function, f of x equals a times b to the x minus h plus k, b is called your base because it's the base for the exponent x minus h. If your base is greater than 1, then it's going to be a growth function. So from left to right, it's going to go uphill. If b is bigger than 0 but smaller than 1, then it's going to be a decay function. It's going to go downhill. And these are used a lot in science classes, so hopefully you've seen them before in some of your science classes with exponential growth and exponential decay. This k ends up moving up and down, so it controls your asymptote. So these graphs, notice they have an asymptote. We approach the asymptote, but we do not cross the asymptote. So that k controls where your asymptote is. Your asymptote is the horizontal line y equals k. What's neat about these functions is you can plug in any number you want, positive, negative, 0, fraction, decimal, it doesn't matter. You can plug anything in for the x value you want. So the domain is going to be all real numbers or an interval notation from negative infinity to positive infinity. But the graph approaches the asymptote, but it never actually crosses the asymptote. So your graph will always either be above the asymptote or below the asymptote. So your range, either y is greater than k or y is less than k, depending on if you're above the asymptote or below the asymptote. In interval notation, above the asymptote would be that you go from k to infinity, but notice it's parentheses because we don't actually touch the asymptote. If it's less than k, then we go from negative infinity up to k. But again, please pay attention to that it's parentheses because we don't actually hit the asymptote. All right, these graphs follow the basic transformation. So these should really start looking familiar. These are all the same transformations we've been doing. We've done them on parabolas. We've done them on absolute value. We've done them on x cubes. So these are all the same transformations that you've already done. So hopefully you start memorizing them. So the h, which is attached to the exponent, well, that moves you left or right. But remember, it goes the opposite. X minus 3 would actually go to the right 3. X plus 7 would actually go to the left 7. Okay, so the k value, the one added to the end, that's going to move you up or down, but not the opposite. A plus 7 moves you up, a minus 7 moves you down. Similar to slope, the a value is either going to stretch or shrink, and it doesn't matter about the negative sign. Notice it's the absolute value of a. So if the absolute value is bigger than 1, it's going to do a vertical stretch. If the absolute value of a is less than 1, it's going to do a vertical shrink. If there's a negative, then it's going to reflect in the x-axis. So that's a negative attached to the coefficient. If there's a negative up in the exponent, negative, and then notice parentheses x minus h, then it's going to reflect in the y-axis. All right, so example 1, we're going to describe the transformations. And so there's no negatives to worry about. So I'm going to look up in the exponent. It says x minus 4, so that's going to move me to the right 4. And then the big minus 7 is going to move me down 7. You always want to do the reflections first, otherwise you end up in the wrong place at the end. So I always look for the negatives first. So there's a negative out front, so we're going to reflect in the x-axis. And the plus 6 is in the exponent, so that's going to move us to the left 6. And 4, the absolute value of negative 4 is 4. That's bigger than 1, so that's going to be a vertical stretch of times 4. All right, so C, again, there's a negative out front, so that's going to reflect in the x-axis. The plus 8 is a big plus 8, so it's going to move us up 8. And absolute value here is 7. 7 is bigger than 1, so it's going to be a vertical stretch of 7 times. All right, so D, we have a negative out front, but we also have a negative in front of our exponent. So this is going to reflect in the x-axis and the y-axis. The minus 9 in the exponent is going to move us to the right 9, and the plus 6 at the end is going to move us up 6. And that finishes page 1, so on page 2, we'll actually do some graphing.